In this lesson, you'll learn how to use the Random.Shuffle function to completely randomize the order of items in a list, perfect for mixing up sequences in games, simulations, quizzes, or decision tools. Unlike Random.Choice or Random.Sample, Shuffle modifies the original list directly, making it ideal for scenarios where you want a new random order every time the list is used. The Random.Shuffle function is different from other random functions because it operates in place. It changes the original list rather than creating a new one. This makes it perfect for situations where you need to randomize content but want to maintain the same list object, and when you want maximum control over unpredictable outputs. For this, we'll be building a music playlist shuffler. We'll simulate a shuffle feature like those in popular media apps using a preset list of tracks. Your Python script will shuffle the playlist in place using Random.Shuffle to apply a brand new order every time it runs. This is a fun and engaging way to see Random Shuffle in action and a great addition to your portfolio, tools, and GitHub. Let's start with defining main. The program opens with a music-themed welcome that immediately sets the context. The playlist contains a diverse mix of classic and contemporary songs, spanning different genres and decades, from Bob Dylan's legendary Like a Rolling Stone to modern hits like Billie Eilish's Bad Guy. Random Shuffle can work with any type of list content, whether it's strings, numbers, or complex objects. After we've created the playlist, we perform our for loop for I, song and enumerate, playlist, start equals 1, and then we print. This section uses enumerate with start equals 1 to create a numbered list that looks like a real music player interface. The enumerate function pairs each song with its position, starting from 1 instead of 0, to match how playlists are typically displayed in music apps. The formatted output creates a clean, professional look that mimics what users see in Spotify, Apple Music, or other streaming platforms. Now we're using Random Shuffle with our playlist. Here's where the core functionality happens. The Random Shuffle playlist line completely randomizes the order of songs in the playlist. This function is perfect for this scenario because of in-place operation. It modifies the original list directly, so we don't need to create a new variable. The complete randomization, every song has an equal chance of ending up in any position. And the content preservation, all songs do remain in the list, just in a different order. And then it's, of course, very simple syntax. One line of code does all the work. Let's again just compare this to our other random functions. The key advantage of Random Shuffle is that it's designed specifically for reordering, making it the most efficient choice when you want to randomize a complete sequence. If you learn these things, remember these things, it'll make it quick and easy for you to make the decisions when you're developing solutions as to which one to use. This music playlist shuffler demonstrates several important use cases for Random Shuffle. Music playlist shuffling, video playlist randomization, photo slideshow ordering, podcast episode mixing. There's a variety of uses. Games, shuffling card decks, randomizing game levels, random challenge orders, mixing up character selection, data processing, randomizing dataset order for machine learning, creating random sampling sequences, shuffling survey questions, randomizing test cases. So when you get in and you run the program, you'll see that every time you run it, you get a completely different order, just like hitting the shuffle button on your favorite music app. So this in-place operations is an important programming concept that's demonstrated by Random Shuffle. Instead of creating a new list and returning it, Shuffle modifies existing lists directly, which is memory efficient, no need to create duplicate data, performance optimized, faster than creating new lists, and convenient. The same variable now contains that shuffled data. Go ahead and run your program, play with it a bit, change the names up in songs and things like that. Commit to Git, push to GitHub, continue to build that online portfolio, and good luck.